Hello, everybody. Welcome to the 32nd live episode of the Ask Abhijit show. And as you know, today we discuss science, which for me is physics and mathematics and astrophysics and computer science, artificial intelligence, all that. It is not sociology, it is not political science, it is not the social sciences, etc. So that's what we discussed today. Let me take a look at who all is here with us today. Hello, Kishore. Thank you, Moshmi. Hi, Prasham. Hi, Ram Kudia. Hello, Simpo. Hello, Koka. Prasham Shah. Hello. Hi, Harshada. Akshar, Omkar, Dungar Singh Chauhan. Thank you, Dungar. Debar, Meet Saha, Kaushik, Jetty, Akash Buller. Good evening. Novak Djokovic, Sudeep Das, Aditi, Ojas, Sagar, Anchit, Sats Gaming, Nitin, Cherry, Vineet, Roshan, Shaurya, Sanjay, and everybody else. I'm unfortunately unable to take everyone's name, but good evening and good day to all of you. It's great to see you all here. So let's get into the questions straight away because that's what we do. Let's start with question 1. Okay, question 1 is by Chahat. So Chahat says that galaxies look stationary. So why do scientists say that they rotate? That's a very good question. So according to what we know about galaxies, or according to what scientists say about galaxies, a galaxy, a typical galaxy like the Milky Way, for example, would complete one full rotation in about 1 billion years or so. Maybe some are faster, maybe some are slower, but something like that, right? So that's a very slow rate of rotation. So how do we know that galaxies are rotating? That's a very good question. I'm sure your teachers never answered this question. I'm sure that you did not even get to ask this question because you can't ask questions in school. So how do we know that galaxies rotate? There is something in physics called redshift and blue shift. You must have heard of the Doppler effect. The Doppler effect is when you are standing stationary and a train is coming towards you at a high speed, and the train's whistle or siren seems shrill when the train is coming towards you. But the moment it passes you, the pitch of the whistle changes, it becomes lower in pitch. So that's an example of the Doppler effect, because when the train is coming towards you, the frequency of the waves is compressed, the wavelengths are compressed, and that's why the sound seems higher. And when the train is receding away from you, that's when the wavelengths of the sound are elongated, and that's why it sounds lower in frequency. So the same thing happens with light. So there is a Doppler effect in light as well. There's redshift and blue shift. When a luminous object is receding away from you, its light waves, the wavelength of the light is elongated, and that's why it appears redder than if it was not moving away from you. And if it's coming towards you, then the light is blue shifted towards the blue end of the spectrum because the wavelengths are compressed. So there's redshift and there's blue shift. So if you look at a galaxy, if you observe one end, then you will find that the light is red shifted. So for example, you have certain spectral lines. For example, sodium and other elements, they produce very specific light. They produce light of very specific wavelengths. And when you observe those wavelengths from a distant galaxy, you will find that at one end of the galaxy, those wavelengths are red shifted, which means that end of the galaxy is moving away from you. And on the other hand of the galaxy, on the other side of the galaxy, you will find that the same wavelengths are blue shifted, which means that they are moving towards you. So the galaxy, one side of the galaxy is moving away from you, the other side of the galaxy is moving towards you. This is clear from the redshift and blue shift that you see from the two opposite ends of the galaxy. And that indicates that the galaxy is rotating, right? So that's one way, one excellent way of determining that whether a galaxy is rotating or not. And we find that all galaxies are rotating, and depending on various measurements, we can actually determine to a good extent the rate at which it is rotating. How fast is it rotating? And that's how we get the galaxy rotation curves, those graphs, which actually showed us that there is missing matter out there. And that's how dark matter came into the picture. Now, what's the other way that we know that galaxies are rotating? Well, most galaxies are spiral in shape. How do you get a spiral shape? Let me show you how you can get a spiral shape. Let me just play a 5-second video for you. Hang on. So that is a ball that is wet and it's been spun like that. And you can see the spiral shape that it's creating. The water is ejected in a spiral shape. So that's precisely what we see in galaxies. The video I just showed you is that of a ball on Earth. It's a very slow motion video, high frame rate, but that's the same sort of shape that you see in galaxies. So the spirals are at a 90-degree angle from the axis of rotation. So that's another way that we know that galaxies are rotating. And that's how we know for a fact, based on this observational evidence, on various different kinds of observational evidence, that galaxies are indeed rotating. We know they are rotating. We can actually measure the rate of rotation, even though we can't see a galaxy do a full rotation, because it would take a billion years or hundreds of millions of years, and we don't live that long, and yet we're able to tell that they rotate. So this is how it's done. Good question, very good question. Pink Line Cabs asks, I have had this doubt for a long time, that despite the extremely small sizes of particles, how do scientists and physicists measure them? So what you're asking is, let's say you have an atom or a nucleus of an atom, basically subatomic particles. So how do we know the sizes of these subatomic particles? So this is a question that's similar to the rate of rotation of galaxies, but it's at the opposite end of that, of the scale. Galaxies are immensely large, subatomic particles are immensely small. And yet we know that the nucleus of an atom has a certain size. We know that other subatomic particles have a certain size. How do we know that? That's an excellent question. Did your teachers ever answer this? I doubt it very much. Right. So here's how it's done. Let's say you want to measure the size of the nucleus of an aluminum atom. So what you do is you take a thin sheet of aluminum, aluminum foil, right? You try and make it as thin as possible, and that is your target. And then you create a vacuum apparatus. You place the aluminum sheet as the target, and you shoot a beam of electrons. Let's say electrons. You can shoot anything, but let's say you shoot a beam of electrons at this target, and you set up detectors behind the target and at various angles around the target, and you see how many electrons are scattered in what direction. So we know that atoms are mostly empty space. It's a nucleus, and you have electrons around that, and most of it is empty space. So most of the electrons that you shoot at the aluminum atoms, they're just going to pass through the aluminum foil, right? They're just going to pass through them. And yet some electrons are going to get deflected from the nucleus at various angles. And in extremely rare cases, you will find that electrons will hit a nucleus head on and bounce back in the opposite direction. So that also is to be measured. So then you determine how many electrons were fired. Okay, you can measure that, and you can detect how many hits you were able to measure behind the target, or at various angles around the target and on the opposite end of the target. And based on these calculations, how many measurements you were able to make at what angles, you can determine the size of the nucleus. So it involves a bit of trigonometry, geometry, algebra, all that, but the theory is pretty simple. So that's how it is done. So basically, let's say you shoot 1 million electrons at a single atom of aluminum, and let's say out of those 1 million electrons, 99.3% just fly away, and they just pass through the atom. But a small percentage will be deflected right back. So that percentage tells you what percentage of the atom is actually the nucleus. So we know that the nucleus is very small. And then based on other calculations, you can determine exactly, or not exactly, but to a good fidelity, how large the atom is and what is the probability of error in that. What is the error calculation in that? So that is essentially how we calculate or we measure the actual sizes of atoms and nuclei. So you can do this with aluminum, we can do it with gold, we can do it with calcium, and eventually you can even do it with hydrogen and all that, right? So that is how it's done, and this is a process that takes long time. In the very beginning, it was thought that atoms are essentially like plum puddings. You have a smeared out charge in them, and later it was discovered that they actually have a nucleus, because they did this very same experiment, and they found that a very small percentage of electrons actually bounced back. And that's how it was discovered that atoms have nuclei. And then this experiment was refined and done over time for over the various decades, and that's how today, because of the improvements in the experimental apparatuses and all that, today we have a very good idea of the size of various subatomic particles. So that is how it's done. This is all about experimental physics. Good question. Joy Saxena asks, my views on the Rosewell UFO incident in the USA. They found alien ships and their remains, but then moved them to some secret location. They must have been in contact with them. That's a very interesting question. So, how many of you actually believe that aliens have actually visited the our planet? Just say yes or no in the comments. Do you actually believe that aliens have visited our planet? Because when I was a kid, I was fascinated with this. I wanted to read about aliens all the time, alien encounters and all that. So yeah, it's very interesting. No, no. Abhi says yes. Sovik says yes. Anand says yes. Ramana says yes. Aryan says yes. Wine Gaming says no. Arjun says no. Cherry says yes. So I think most of us, Harshada says no. I think Harsh says possibly. I think the overall consensus seems to be towards a belief, or yeah, towards a belief that aliens must have visited us. I am a little skeptical about this, right? Because we don't have hard evidence. So here's my view on the Rosewell. Okay, first of all, what do we know about this incident? So this is something that happened in 1947, I think. Okay, uh, in the first half of the year in 1947. So what happened was that uh, something crashed from the sky, which looked like it was out of the earth. It was nothing like something. It was nothing that would be made on the earth. That sort of thing. It was metallic. The crash debris were metallic and very strange. And it was even announced in the local newspaper that the local police department, or whoever the authorities were, they had recovered a crashed flying saucer. That, I think, that was the headline in the newspaper. And a couple of days later it was changed to say that this was actually a weather balloon. And there's been allegations of a cover up for decades. This has been going on. And people say it is alleged by various people that it was indeed a UFO, and there were even aliens in there. A couple of aliens had died, and maybe one or two were recovered alive, and they were taken away somewhere. There were alien autopsies apparently, and so on. And then all the debris of this flying saucer were carted off somewhere else, and they maybe are in Area 51 or something like that. So that is what is believed by a great many people. Now, the US authorities deny this. They say it was a weather balloon. So there was something called Project Mogul that was going on at the time. So this was a project in which the Americans would place high sensitive microphones and other equipment on weather balloons high up in the atmosphere, with the aim of listening to certain kinds of sonic signals, acoustic signals that would indicate a far away nuclear explosion. So we know that the Soviets and the Americans were engaged in this nuclear arms race. The Soviets were testing nuclear weapons at the time. It was done. These were atmospheric tests, which means that these nuclear weapons were detonated above the surface of the earth. Later on, it was mostly underground, but at the time, it was atmospheric tests. And these sound waves of these explosions would travel around the globe, but after they went far enough, they would not really be that detectable. So the aim of Project Mogul was to place highly sensitive microphones and other equipment high up in the atmosphere on weather balloons and listen for such signals. And the US authorities say that it was one of these weather balloons with all the assorted equipment that crashed in Roswell, New Mexico. And the equipment was highly scientific and all that, various kinds of complicated apparatuses, all that. And that's why it looked like it's something from out of the world. So that's what the US government clarified in the 1990s, I think. So there were some clarifications that there were issues issued by the authorities, US authorities, in the 1990s, I think in the 1990s. And yet there's been a lot of skepticism about that. So many people still believe that there's a cover up that has happened. So what do I know? I mean, unless you're part of some secret society, Ashok's 9 secret men or something, unless you're part of that, you won't know about this. So I don't know. Okay, whatever information we have is in the public domain. uh, the American authorities say that it's been debunked comprehensively. UFOlogists, they say that it's not been debunked and they are trying to cover it up. So the jury is still out there. I am skeptical by nature. That's what you have to be as a scientist. You have to be skeptical. You have to always look at the more rational explanation. And I would say that the more rational explanation would be a weather balloon or something like that. And yet there is always the possibility. I don't think they have been able to comprehensively prove that this was just a weather balloon. It's just a claim. It's one claim another against another claim. So unless we actually are given the evidence, we can't really tell. So I think the jury is still out there. 90% I would say it's not an alien thing, but maybe 10% it may have been. So that's where I am about this. I am skeptical, but I'm still open-minded. It possibly may have been an alien spacecraft, but so the evidence may have been even destroyed by now. We don't know where it is. So how do we prove that aliens have visited or are visiting? Well, we have to find good evidence today. These days you have all this media frenzy about alien visitations, UFOs and all that, especially in North America. I think only in North America. So I would like to see evidence from that, not from the US government, but from civilian sources. Something that some alien UFO phenomenon that is captured on camera, not black and white grainy footage, but proper footage, and not just one person, but many people simultaneously. Then I would really believe it. So that's what we still seek, and so that's where we are today, as regards to UFOs. Aditya asks, could there be intelligent life on Proxima Centauri B? Does intelligent alien life only mean super advanced aliens? I mean, they could also be in their medieval ages or something like that. A good question. So what is Proxima Centauri B? So the nearest star system to our own is the Proxima Centauri Alpha Centauri. It is that star system. It's about 4 light years away from here, 4.5 light years away from our solar system. And they have recently discovered a planet. I mean, there's a number of planets there, exoplanets around this star system. I think it's a triple star system. It's 3 stars, okay, in this system. You usually have a single star like the sun. Sometimes you have a double star system. But in the case of the Proxima Centauri system, there are 3 stars in this system. And you have a bunch of planets around them. And one of these planets is Proxima Centauri B. So it is in orbit around the main parent star, which is a red dwarf. Now, this main star is a very small, very cool, very dim star. It's a red dwarf. It is about 10% of the mass of the sun, roughly. And this exoplanet is in the habitable zone. It's about 20 times closer to its star than we are to our sun, right? So that's the thing. And this exoplanet is slightly larger in mass than the Earth. It's between 1.2 and 3 Earth masses. So now we don't exactly know what are the conditions on this planet. It is in the habitable zone, which means that if that running water would be available there, if there is actually indeed any water on the planet. Now, there are certain things that we need to know further. Is this planet tidally locked with the star? So what is tidal locking? It's like the Earth-Moon system. The time that it takes for the moon to rotate on its axis is the time that it takes to revolve around the Earth. So one rotation is exactly equal to one revolution. And that's why it is tidally locked with the Earth, and we only see one face of the moon. Right? So this is something that happens over time in such systems. So in case this planet Proxima Centauri B is tidally locked with its parent star, then one side of this planet would be permanently facing that star, and the other side would be permanently in darkness. In that case, you would have a very strange scenario in which half the planet is hot and half the planet is freezing. So that would not be conducive to life on the planet. The other thing is that it's very close to the star, and therefore solar flares from its parent star may be uh, may be a threat to any possible life on that planet, unless it has a strong magnetic field, in which case these solar flares, stellar flares, would not be that much of a problem. So there are a number of situations, circumstances, parameters that we need to know before we can tell whether there is life or not on this planet. Does intelligent life mean only super advanced aliens? Not at all. Uh, Intelligent life, I mean, I would consider even a dog or a cat or a dolphin or a whale to be reasonably intelligent, right? I mean, we can communicate with dogs and cats. They are different kinds of animals. I mean, even whales, we can communicate with whales. They seem to have intelligence, reasonably good intelligence. They even seem to have emotions. Many animals do. So there are different levels of intelligence and different levels of consciousness. So I would not say that only super intelligent aliens would constitute intelligent life. I mean, 500 years ago, this world, our planet, was in a very different condition, right? And still, it was our intelligence level was very much the same. So yes, if there are intelligent beings somewhere, then it could be that it's very possible that they could be in the medieval ages or something like that, and they may not have the kind of technology that we have today. It is possible. So I hope that answers this question. Okay, Indilas, what's your take on the Fermi paradox and the great filter? Is it possible that the great filter is ahead of us? That's a very good question. So let's first look at the question of what is the Fermi paradox, right? What's the Fermi paradox? So it's basically about the occurrence or not of intelligent life out there in the universe. So we know that there are about 100 billion galaxies in the observable universe, based on the data that we have. About 100 billion, which is one with 11 zeros after it, right? And we know that there are approximately, roughly, 100 billion stars per galaxy, roughly. You know, so that would mean that there are about 10 to the 22 power of stars in the universe, which means one with 22 zeros after it. These many stars in the universe. Now, let's say only 1% of these stars are sun-like stars, for the sake of argument. Then you would have 10 raised to 20 such sun-like stars. And let's say only 1% of these stars have Earth-like planets. Then you would have 10 raised to 18 Earth-like planets in the observable universe. And let's say 1% of these planets would develop life. Then you would have 10 raised to 16 life-bearing planets in the universe. And let's say 1% of this would develop human-like intelligence, which would give us about 100 trillion human-like intelligence-bearing planets in the observable universe. And if you do the same calculation for the Milky Way, you get something between 4,000 to 1 lakh human-like intelligent civilizations in our own Milky Way, right? So then the question is, if you have these many possible human-like civilizations in our own Milky Way, then the question is, where are all the aliens? Where are they? Why do we see no signs of these aliens? And that is called the Fermi paradox. Our calculations tell us that there should be an abundance of human level intelligent life in our galaxy and in the observable universe, and yet we have seen not a single sign of that. A single sign of that. That's the Fermi paradox. So how do we resolve this paradox, right? And that is where we come to these filters. So there is one possibility there which says that there are no higher civilizations in the universe. There are no higher civilizations than us in existence anywhere, because there is a great filter. So what is this great filter? It is an evolutionary wall that destroys life once you advance to a certain stage. Maybe it's nuclear war. Maybe you kill each other because of some other form of warfare. Maybe it's some disease, or maybe life just isn't meant to evolve past a certain stage. So that's called the great filter. right? The possibility too is that we are a very rare civilization. The level of our intelligence is very rare in the universe, which would essentially indicate that this great filter is behind us. We have managed to surpass this great filter. It says that it is extremely rare for life to make it to our level of intelligence, right? So maybe this great filter that is spoken about could be at the very beginning of existence. Maybe it's incredibly unusual for life to begin at all. So maybe we are the first life that exists out there. So that is one of the possibilities, right? There is another possibility which says that the great filter has not yet come up. We have still not come across the great filter, which means that basically we are in trouble because the great filter is ahead of us. It's there in the future, and we're going to run into the great filter, and it's going to annihilate our existence. I mean, we know that we have had many species of human beings on our planet: Homo habilis, Homo erectus, Homo neanderthalis, the Denisovans, Australopithecus, Ardipithecus, and so many more. So many species of humans and hominids came before us. We have some of their genes in us, and yet they have gone extinct as distinct species. So they ran into some filter, right? So that's what we mean by the filter. So maybe there is a filter ahead of us in the future, which means we are screwed basically, right? And then there are other possibilities that maybe intelligent civilizations are out there, and maybe there are some good logical reasons why we have not heard from them, or we have not been able to detect them. Maybe uh, maybe super intelligent life may already have visited Earth, but maybe they did before we evolved as humans, and maybe before we became intelligent enough. So maybe they came before us, perhaps. Okay. Or maybe the galaxy has been colonized by a Kardashev type 2 civilization, but we just live in some desolate rural area of the galaxy that nobody cares about. Yeah, so that's another possibility. And maybe there are some extremely dangerous predator like civilizations out there, and most intelligent life knows that we should not broadcast any outgoing signals and advertise where we are. And maybe we are extremely naive to be advertising our existence to whatever is out there or whoever is out there. And then there is a possibility maybe we are receiving some contact from intelligent life, but our governments are hiding it, right? So there are a number of such possibilities. Maybe there are civilizations so advanced that we are too primitive to perceive them, so these are the possibilities. And so that is what the great filters are. This is the Fermi paradox. And that is this entirety, what I just outlined, is the kind of debate that is ongoing about this matter. Akash asks, is mathematics invented or discovered? What are the chances, for example, that the area of the circle of a circle is pi squared for every advanced civilization in the universe, if they exist? So to answer this question, we have to first ask ourselves, what is mathematics? What is it? So mathematics is something that expresses the patterns and the regularities in the universe. It is a language that expresses these patterns and regularities in the universe, right? So the universe has patterns and regularities, and mathematics is a language that perhaps we have invented to express in the simplest possible form and the most concise possible form these patterns and regularities. So we are discovering these patterns and regularities, but we are expressing them in a language that maybe we have invented, right? So we do discover things in mathematics, and we also invent techniques to discover things in mathematics, right? So if there are intelligent aliens out there, maybe they use different notation for doing their mathematics. So maybe it's a different language that they've invented, and it's a different language that we have invented, right? But these languages, whatever they are, they do express the same things about the universe, the same patterns and regularities. So mathematics is invented, it is also discovered, because we are discovering facts about the universe. For example, mathematicians are always several steps ahead of physicists. They talk about infinite dimensional spaces, they talk about various things that physicists have no use for, and then 100 years down the line, we suddenly find a use for one of these things that mathematicians have been doing, supposedly random abstract things that mathematicians have been playing with. For example, you have group theory, Galois theory, which was discovered in the 19th century, or discovered, invented, whatever you call it, by a French teenager, right? And for 100 years, it had no application of any kind. It was something abstruse and abstract, and suddenly today, in the 20th century, it found a great use in particle physics. In symmetry, in the symmetry groups in particle physics. So that's an example of how ahead of the times mathematicians are. So they discover things about the universe, regularities and symmetries of the universe, and they express them in the language of mathematics. And like I said, they also invent tools and techniques to solve problems which enable them to make discoveries about the universe. For example, you have various differential equations and tools and techniques of solving differential equations and matrices and numerical analysis and whatnot. So these are tools that are invented to make discoveries. So I would say that mathematics is both invented and discovered. It does tell us something very profound about the universe. It does help us understand the universe better. There's only one mathematics. There are no parallel branches of mathematics that differ from each other. 2 plus 2 is always 4. And the area of the circle is always pi r squared, right? So unless you're on a curved surface, in which case it's something else. So in curved geometry, the area of a circle is different, etc., or a triangle, etc. So that's how it is. So for example, Pythagoras theorem, we know what it is on a flat surface. It's different on a curved surface, but that holds true for the entire observable universe as far as we know. So to make it short, I think mathematics is something that is invented as well as discovered. Tools and techniques of mathematics are invented, but the deep underlying patterns and regularities of the universe that mathematics expresses are actually discovered. So that's what mathematics is. It is the most logical language that we have, and it's the language of physics. So there's no physics without mathematics. Abhilash asks, can we create life using science, or is there a soul, Atma? That's a good question. So people have been trying to do various chemical experiments to try and replicate the environment that was present in the very early Earth, when the Earth was very young, about 4 billion or so years ago. The Earth is about 4.5 billion years old, if I am not very mistaken, roughly that much. And the very early Earth was very different from what it is today. It was hell. We would find it hell. That's how it was. It was a very hot, dense, swirling environment. There was a lot of bombardment happening from space because of various impacts from space debris from the early solar system. The atmospheric composition was very different. The planet was very hot. The gases were different and all that. And that is the environment in which life first emerged on our planet. So scientists, chemists, biochemists, etc., they try to replicate that environment in a test tube, and they try to create and they try to see if life can emerge from there. So what they find is that various complex organic compounds, carbon compounds, do emerge from that. Even amino acids, etc., they do emerge from these experiments. When you take these mixture of gases and liquids and you put them in a test tube and you heat them to a certain temperature, or you pass electricity through them and all that, and you keep doing that for hours or days, then you find that complex chemistry does arise out of it. And yet we have never been actually able to create life, unicellular life or anything like that out of it thus far. So thus far, it seems that we are unable to create life out of chemicals and chemistry and using science. Thus far, it's not been possible. Maybe it may be possible in the future. We don't know the exact origin of life on our planet. Did it actually emerge spontaneously in the primeval atmosphere and environment of our planet, or is it something that was seeded from outside from a cometary impact? Is it some this the panspermia theory says that DNA and the seeds of life may have come from interstellar space, because we find that certain asteroids and meteors and even comets contain complex carbon compounds, organic compounds, even amino acids, etc., that are, we know, they are the building blocks of organic life. So the jury is still out there. We don't know where life came from. Thus far, we have been unable to create synthetic life forms using chemistry, biochemistry, etc. So as of today, it's not possible. In the future, we don't know. It may perhaps be possible. And now, what about the soul? Well, the soul is there is a dividing line between science and philosophy, right? Science is a subset of philosophy, but philosophy, so science is a part of philosophy, but philosophy is not a part of science, and spirituality again is not part of science. Science deals with observable phenomena and physical objects only. That is the limitation of science. It has very hard boundaries. Only physical objects, only observable phenomena. Now, the soul is not a physical object. I think everybody would agree. And it's not an observable phenomenon, right? We cannot see the soul. We can't measure it. We can't detect it. We don't know its properties. It doesn't have physical properties. It is believed to be something that transcends the physical world, right? And therefore, it is not something that science can describe or experiment or even talk about. It is something that belongs in the realm of philosophy and spirituality. I am not in any way denigrating the concept of the soul, or I am in no way trying to mock anybody who believes in the soul. I think most people on this planet believe that there are souls in human beings and other beings as well. I'm sure even lots of scientists believe it, whether they express that belief or not. But the concept of the soul is not something that's part of science, and therefore I cannot answer the question as a scientist whether there's a soul or not. As far as we know, we have never seen any experimental evidence or observational evidence of the existence of the soul, and yet one cannot rule it out, even from the perspective of science. Something that has not been observed doesn't mean it doesn't exist. The absence of evidence is not the evidence of absence, right? So the soul is something that is beyond science. Maybe in the future, someday, science may advance that much that we may actually be able to perhaps detect the soul, if it does exist or not. But as of today, I can't say. I have no evidence that the soul exists or doesn't exist, right? So that's where we are from the perspective of science today. Okay, according to Johann Rockstrom, we have only 3 years to reverse the growth in greenhouse gas emissions. If we are going to reach the goals set in the Paris Agreement, this was said in 2018. My question is, what if we fail to meet the goals of the Paris Agreement? Will it be too late for humanity to survive on Earth? And do we ultimately have to find another planet for our species? Okay, so I'm not very sure about what were the exact goals given in the Paris Climate Agreement. Unfortunately, nobody in the leadership positions of various nations, especially the geopolitically powerful nations, nobody takes climate change seriously. Climate change is, well, it's not taken seriously. Geopolitical goals are more important than climate change. And it's very clear that whatever goals were set in the Paris Climate Agreement are not going to be met. Greenhouse gas emissions continue to happen. And global warming is a fact. So we are going to have continuing global warming. And in a century or two, the planet will be several degrees warmer than what it is today. That is going to happen. There is nothing that is being done to stop it, and it may even not be possible to stop it, because the process of climate change through greenhouse gas emissions was set in motion at least 2 or 3 centuries ago with the Industrial Revolution in England and in the Western world. So that's where all the emissions came from. It happened for centuries. Today, they are trying to shift the blame to the to the developing countries, especially China and India. But the point is that we are already beyond perhaps the point at which we can stop, or even stop or reverse the climate change and global warming. Will will this make it impossible for humanity to survive on earth? No, not at all. Humanity will continue to survive. Humanity has always adapted and evolved. There have been terrible ice ages in the past. There have been times of global warming as well in the past. Climate change is has always been there. The climate has always been changing. Right now it's happening because of man-made processes, but in the past it happened because of other things as well. Our ancestors 65 million years ago survived the worst weekend in living, I mean, in the past 100 years of 100 million years of the earth's history, the Chicxulub impact event, which wiped out the non-avian dinosaurs. There was a terrible climate change event that happened because of this impact event. There was a nuclear or climate winter that lasted about 10 years or so. There was no sunlight for that period of time. Almost all life was wiped out on the planet. But our ancestors, those little shrew-like mammals, they survived it. So the point is that human beings are resilient. We will survive, but it won't be a good time for us. Life as we know it may not continue to exist. Our lifestyles may have to change drastically. Maybe there could be population die-offs in certain parts of the world, in less privileged parts of the world. So these things may happen. There's nothing we can do to stop it. Even if every nation were to try and stop this thing, which is not going to happen, even then we may be at best be able to slow climate change down or slow the global warming down. So I think it's currently an irreversible process. We are on track to see 2 or 3 degrees of warming in the next 50 to 100 years, maybe more warming. I'm not sure. I've not studied the literature, but it's going to happen. The bigger problem is the proliferation of plastic in our oceans and in our water sources. Basically, what we are finding now is that even bottled water that is purified, etc., contains microplastic particles. And that is going to pose a long term health hazard for us and for our descendants. We're basically poisoning everything with plastic. The Western countries started adopting plastic about 100 years ago, and they have this culture that is like a disposable culture. Everything is to be used once and then thrown away, and all of it was dumped into the oceans, and today we are paying the price of that. Today you have this enormous mountains of garbage and plastic floating around the oceans. So all these things are going to be a significant factor in the future of humanity, and we still don't know how it's going to affect us. So as of today, this is something that cannot be changed. The Paris Climate Agreement, whatever goals are there, are not going to be met. I think humanity will survive, but the future is going to be very challenging. Will we have to find another planet? Well, the only planet we have out there is Mars, and it's currently not inhabitable for human beings, unless you are one of the very small billionaire class, in which case you may be able to move there in the next 30, 40, 50 years. But the common population of Earth, the average human being, they are doomed if something were to go wrong on the planet, on our planet here. So that is the situation we are in as of today. Aditya asks, are we capable of avoiding a human extinction by an asteroid? As of today, from whatever calculations, computations, simulations we have done, we are not in a position to avoid human extinction if a sizable asteroid were to be heading our way. So there are a couple of possibilities people have thought of destroying an asteroid. It always involves a nuclear weapon. Take 100 megaton or so nuclear weapon, throw it, shoot it, launch it at the incoming asteroid, and detonate the nuclear weapon near the surface of the asteroid. So they have done simulations of such a nuclear blast on the surface of an asteroid. And you know what they found? They found that the nuclear blast, if it is powerful enough, will fragment the asteroid. The asteroid will be blasted into small pieces, and it will be blown apart in different directions, and then gravity will take over, and the millions of different pieces of the asteroid will reassemble together, and it will become one single asteroid again. So that's what happens when you fragment an asteroid with a nuclear weapon. It makes no difference whatsoever. Its center of mass remains more or less the same, and all the fragments over time reassemble, and within a week or so you will have the asteroid reforming and coming towards you as if nothing had changed. So as of today, we can't use nuclear weapons to destroy an asteroid. Even if we destroy it, it will reassemble like by magic. The other possibility is that of using a gravity tractor. So you send a satellite or spacecraft near the asteroid, and you use the small gravity of the spacecraft to slowly tug the asteroid away into a different trajectory. And you do this over a period of a few months, and you do this so that the trajectory will be just enough so that it will, instead of hitting the earth, miss the earth. So that is one technology that we have the means to actually test. It's not been tested yet. I think it is something we should think about very seriously. It is something we should try out, so that in case we detect an asteroid like that, we can actually use this technology. But as of today, as of the end of July 2021, there is no way to currently avoid a human extinction event by an asteroid. Narayan asks, what are your thoughts on big data? So, big data is these large, enormous social media and other companies in the US mostly that aggregate our data and information. You have Facebook, you have Google, you have Instagram, which belongs to Facebook, I think. You have Twitter, uh, YouTube, etc. So you have all these different social media and big data platforms that have access to our personal information. They are able to track our doings, whatever we do, our movements and whatnot. And basically, we are feeding them with our data. So they know where we are, they know our GPS information, they know what kind of browsing history we have, they know what our likes and dislikes are, they know what we click like on, what we click thumbs up on, they know what we click thumbs down on, they know where we put our hearts and whatever else, they know what we comment on, they know our browsing habits, they know our shopping habits. They know more about us than we know ourselves, because all of these disparate data points, they can be aggregated together to create a very detailed psychological profile of every individual. And using these individual psychological profiles, you can create psychological profiles of entire demographics, males, females, age ranges, geographical regions, countries, etc. Right? So if any organization or any power had all of this data, then they would actually be able to see in real time the mood of a country or a region in a country. They would be able to to influence the mood of a country or a region just by trending certain things, certain hashtags, certain news stories, etc. And all of this data, it is extremely valuable because it can be mined. This data can be mined and exploited to make you buy, to induce you to buy certain things or cultivate certain habits and whatnot. It's enormously powerful data. Like they say, like the cliche goes, is the new oil. And all of this data currently is owned by the United States. All of these companies are US companies, and that's what is happening right now. It is a very scary prospect. We all benefit from it. It makes our life so much easier. Our cell phone, our computer, our tablet knows what it's like. They can read our mind. They know exactly what we want at what time, right? And they show us information and things that make us happy, etc. But do this because they're able to hack into our psyche. They're able to read our psyche, and they know us better than we do. There is something called predictive analytics. So they're able to predict our behavior in the future, right? So that's what big data is. Sociology is passé. Sociology is obsolete. These teachers in sociology departments, their sociological theories are finished. They're of no use anymore. It is big data that has perfected applied psychology and applied sociology and applied psychoanalysis. This big data, all of this information, all these data points, these trillions of pieces of data points, that's what constitutes real psychology, real analysis and whatnot, right? So they are the real sociologists and psychoanalysts, and that's what they are doing. And they can actually uh, make the world think differently. They can influence the world very subtly, but the overall effect is very powerful. So that is what big data is. It is extraordinarily powerful. It permeates everything. It doesn't recognize national boundaries. It doesn't recognize national sovereignty. Governments are helpless in front of it, unless you're China, because China has the great firewall of China, and they don't allow their data to be shared with the West. And to some extent, even Russia does that. So the countries that have some geopolitical standing, geopolitical ambition, countries with good leadership, they are able to ward off this threat from the United States and from the West. But other countries that have, well, other countries, they don't do it. So India is basically thoroughly permeated with the big data companies, and they know more about us than we know ourselves. So essentially, this could very quickly, very soon, and very possibly lead to something called digital colonization. We will be colonized by the West without them ever sending a single soldier into our physical, into our geographical sovereign region of sovereignty, because software and the internet and big data doesn't need, it transcends geographical boundaries and political boundaries. So we are on the verge of digital colonization. It will basically make the rich richer, the powerful more powerful, and the less privileged even less privileged. And those countries that are geopolitically weak, it will make them weaker. It may render them irrelevant. So that is what big data is. It is something that is very useful for the individual. It makes life very convenient for the individual, and yet on a geopolitical scale, it is a very significant threat to the sovereignty and independence and long-term existence of various countries. Okay, Elon Musk, Mark Zuckerberg, Jack Dorsey, etc. support UBI, Universal Basic Income. Will UBI be the only source of income when artificial intelligence gains consciousness and be able to do any kind of human work, creative or routine, better than humans themselves? So you're asking a question about universal basic income. It's something that many of these billionaires have supported. That's the kind of thing they are espousing, universal basic income. So, in the past, in the 1950s, 60s, etc., you had these science fiction writers who had this very utopian view that advances in science will make work unnecessary. So all the technology, all the science, all the robots will do all the work, and humans will live a life of leisure. They will not have to work anymore. And yet the situation that we are in today is that we have the means and the technology to eliminate a lot of the work that people have to do. And yet the capitalist system is such that if you don't work, then you don't get to eat, right? You have no wages, and basically you are either homeless or starving, or you are dependent on handouts from the state. So the system is such that it ensures that people have to work. And if you lose your job, if technological advances make your job redundant, then basically it's a big problem for you. So the system hasn't evolved with times. The system is supposed to serve the individual, but it actually serves the state and various individuals. I am not in any way espousing socialism or Marxism. I abhor those principles. But capitalism is equally dangerous, and it is equally bad, right? So the one solution that these people suggest is that everybody is given a universal basic income, which will ensure that they can live a life of reasonable dignity and reasonable means. They are able to survive, etc., and so on. So it will basically create two classes of people: the people who subsist on UBI, universal basic income, and the people who are productive in the new system, and the people who get rich. So it's going to exacerbate the class divide, the income divide, etc., that already exists in the West. The United States has a very high Gini coefficient. It's one of the most unequal countries in the world. There is an enormous disparity between the rich and the poor. They talk about India. Well, the US is far worse. That's something the Western media and even the Indian media want to speak about. So, this universal basic income concept is going to just, well, it's not a bad concept. But it will ensure that nobody starves, nobody goes homeless. And yet, it's going to create this, it's going to widen the divide between the haves and the have nots, right? So, I don't think it's the best solution. We need a better system. We need to uh, evolve a better system, a system that doesn't exploit people like the way that capitalism does. We need a better system. I don't think UBI is a good long-term solution. We need to change the system. UBI ensures that the capitalist system that keeps creating trillionaires, it will exist. It will keep existing. And they are trying to basically say that we're gonna give you some handouts so that you don't feel too aggrieved. I don't think that's the right solution. We need a better system. We need a better solution than this. Okay, Akash asks about the Philadelphia experiment. A person named Carl Allen said that the US Navy conducted an experiment in 1943 in which a destroyer called USS Eldridge vanished from Philadelphia Naval Shipyard and was seen about 500 kilometers away in Norfolk, Virginia, in an instant, and again reappeared in the shipyard. So this looks like a hoax to me, but it's a popular myth or urban legend. It was deemed possible because the US military had solved the unified field theory with the help of aliens. My question is, what is this unified field theory and what are the chances that this was a true incident? So in my understanding of physics and science, there is no technology that exists today that can make any object disappear from one place and appear instantaneously somewhere else and then reappear back in the original location. There is no such technology in existence as far as I know. So from that understanding, I would say that this is a hoax or an urban legend. Now there is some talk about the so-called unified field theory. So Albert Einstein was working on unifying quantum mechanics and general relativity. So that's what we are still trying to do as physicists. We are trying to find a unified, what's called the grand unified theory. The unified theory, field theory, is something similar to that. So that's what Albert Einstein was working on. He was never able to create a unified field theory. He was never able to discover this unified theory. He was never able to unify these two very disparate pieces of branches of physics together. So it's never been done. And even if he was able to to create a unified field theory, what are the applications of that? How do we know that the application is that we can make objects apparate elsewhere instantaneously, right? So it basically goes against every known law and principle of physics. There was even some talk about sailors becoming sailors merging with the infrastructure of the ship, their arms and legs and limbs becoming entangled with the hull and all that. So there is no technology that we know of that is capable of doing this. And the unified field theory is still something we are searching for. It's something we are still seeking. Nobody has been able to unify quantum mechanics and general relativity, right? And the best field theory that we have as of today is quantum field theory. Now, there is no actual practical application of this sort in quantum field theory. And therefore, my conclusion from what I know is that this has to be either a hoax or what do you call it? An urban legend, right? There is no hard evidence that has been provided that this actually happened, and there is no way it can actually happen. This basically is something that would happen in not in science fiction but in fantasy. So from my perspective, it is 99.999% a hoax or an urban legend. Harsh asks, what is the barrier that humans are facing in exploring the Earth as a whole, as there are great unknowns in both the ocean and on land, although we think that we may have mapped most of the land mass. And how will humankind hope to explore other planets when the project of mapping and exploring their own planet is incomplete? So, first of all, even if the project of mapping your own planet is incomplete, it's definitely possible for us to land on the moon and soon on Mars as well. So, it's something we can certainly do. But you are absolutely right, Harsh, that we don't know much about our own planet. We don't know. I think more than 90% of the oceans are unmapped. We know we have a topographic map of the bottom of the oceans, right? We are able to map the bottoms, the bottom of the ocean with various technologies, but we don't really know what's going on in there. We know how deep it is, what are the shapes and contours of the underwater, undersea mountains and valleys and canyons and all that, but we don't know what species of life live down there. Most of it is in darkness. I think below 100 or about 300 meters, the ocean is permanently in darkness. There's no sunlight that reaches there. So there's a lot. I think more than 90% of the ocean is completely unknown to us. We don't know what species live there. We don't know what's going on in there. There's this aircraft that disappeared somewhere and which it's never been found. The Malaysian Airlines M370, was it? That one. A few years ago, there was an Indian Air Force plane that disappeared somewhere in the Bay of Bengal. We never found it. So the ocean is a big mystery. It's very hard to find things in there. So you are right. We don't know much of the surface of our planet. We don't know much of the the oceans. We don't know much of the oceans. The surface of the planet, we know most of it, but we don't know what happens inside our planet. I mean, even if we were to dig a hole 10 kilometers deep, we would find something new and completely unexpected down there, I'm sure. Recently, we have found evidence of microbes that have been embedded in rock that is millions of years old, and those microbes are not dead. So we are finding staggering new discoveries such as these, right? And we don't exactly know the internal composition of our planet. We have a good idea that there is a molten layer of magma. Then you have other layers. You have a core that is the outer core, which is of liquid metal, the inner core, which is solid metal, which is very strange, unusual properties, etc. And there is an electric field. There's a magnetic field that is generated because of this internal structure, this liquid core, etc. And yet, it's all based on inferences. We haven't really gone and explored these parts of our planet. So you are absolutely right. We know very little about our planet. It's like there is a ball on which you have a bunch of ants and they think they know everything about it. Actually, they don't know anything about the planet. So that is the kind of situation that human beings are in. We don't even understand our own planet to any great degree. So that's where we are. There are great unknowns, like you say, but it's not going to prevent us from going to other planets and exploring those as well. So that's going to happen for sure. Indu asks, technology and artificial intelligence are replacing unskilled laborers in almost all the industries. Will the amount of employment that the tech industry creates equalize or offset the amount that it takes? So, what you're saying is that technology, artificial intelligence, and all that are making lots of jobs redundant, right? And basically, these are the unskilled jobs that unskilled people would do. Those are the first ones to become redundant. Eventually, uh, jobs that require greater skills and proficiency will also start becoming redundant. That is the direction in which we are going. There's nothing we can do to stop this progress of technology. All we can do is evolve and adapt and evolve. So, for example, when the industrial revolution happened in the West, in England, etc., lots of jobs were made redundant. So people had to reskill themselves. They had to learn new skills and adapt to the new uh, environment and situation. So similarly, as of today, lots of unskilled jobs will disappear soon. Within this decade, it's going to happen. We can't stop it. So the only alternative, the only thing we can do as people is to adapt and evolve. The people who don't have skills need to find ways to upskill themselves, learn new skills, and learn skills that are relevant and valuable in this new high tech environment and age that we are living in. So that's what needs to happen. We need we need, as governments, our governments need to ensure that they provide the means for these unskilled people to acquire new skills, and not just skills like carpentry or gardening or something, but I mean high tech skills. That's what takes a country forward. Farming is not a skill that takes the country forward. So I would like to see governments in various countries, including our own country, India, to provide sufficient opportunities for people who lack the skills to acquire those skills, and that's how we are going to be able to mitigate this problem. But to answer your question in brief, this new technological environment, this new technological paradigm that we are in, it's not going to create new jobs, it's going to take away jobs. So it's going to be a problem for countries that don't adapt and evolve. So that is what needs to happen. That is the solution. Kostov asks, are you satisfied with the Copenhagen interpretation of quantum mechanics, as it's the most successful uh, notion of the theory till today, or do you consider the many worlds interpretation to be a bright prospect? So the Copenhagen interpretation is the great victory of Niels Bohr over Albert Einstein. There was this great set of debates these two uh, towering scientific towering physicists had in the 1920s and 30s. I don't remember the exact time frame, but they had these debates about the meaning of quantum mechanics. So when the this new science emerged, quantum mechanics, it was all bits and pieces. They were trying to put things together. They were trying to understand what it is telling us. And slowly, first you had the notion of the quantum, that energy is quantized, that you have a quantum of light called the photon. Then you had the then you found it was found that energy levels in atoms are quantized. The atom was discovered, electron, proton, neutron, etc. Then there was the Bohr model of the atom, and so on and so forth. But the question was, what does quantum mechanics tell us? There were these great paradoxes. You had wave particle duality. Particle of a particle can be a particle, it can be a wave at the same time, right? A photon is a particle as well as a wave, and so the same for any other particle, right? So you had this thing. Then you had the problem of the collapse of the wave function. A particle doesn't have any properties when it is not being observed. It is just a set of probabilities. So these properties are meaningless unless you observe it. It doesn't even exist in one place at the same time when it is not being observed. And when you make an observation, when you make a measurement, the wave function of the particle collapses into one single state. Before that, it was a superposition of states. So the Copenhagen interpretation of quantum mechanics says that the properties of a particle have no meaning before a measurement is made. It's just a set of mathematical probabilities. So the properties of a particle are meaningless until and unless you make a measurement or an observation. And Albert Einstein was against that. He said that properties should exist, and he proposed a number of other alternatives. So according to the Copenhagen interpretation, particles, the measurement or observation of a particle causes the collapse of the wave function, and before that the particle doesn't really exist. It's just a set of probabilities. And it is best expressed in this famous line, shut up and calculate. Don't ask philosophical questions of what the particle was doing before you observe it. Just calculate, use the laws of quantum mechanics to calculate uh, whatever you're calculating. And that's how you make progress. And that's how all the quantum mechanics based technologies have evolved that made the 21st century possible. So it's been a very successful interpretation. Most physicists believed in this interpretation until recently. Now you have more and more physicists who are leaning towards the many worlds interpretation, which is due to Hugh Everett, uh, who was a so Hugh Everett is the physicist who put forward this competing interpretation of quantum mechanics, which says that every time a measurement or observation is made, the wave function seems to collapse, but it's actually branching off into two different paths, in two parallel universes, into parallel worlds. So what you see, the collapsed wave function, is what you see in this specific universe. But in other branches of the timeline of the particle, the other possibilities are still present. So every time you make an observation, the world splits off into two universes. Every time you think about something, every time you make a decision or a choice, every time you flip a coin, the world splits into two branches. So that is, in very brief and very roughly, the many worlds interpretation of quantum mechanics. It is physically consistent. There is nothing wrong with it if you examine it properly and deeply. So what is my stand? I think the many worlds interpretation is very interesting. I think the Copenhagen interpretation is limited. I am sure that there is more to quantum mechanics than just a set of probabilities of a particle when it is not being observed. There has to be something more. That's my gut feeling, and that's the gut feeling of many physicists. So well, I would think that the many worlds interpretation is very interesting, and it should be something that should be investigated further. So I am not firmly in favor of one or the other, but I think the many worlds interpretation is very interesting, as are some other interpretations of quantum mechanics. The Copenhagen interpretation has been very successful in taking science forward. It's been successful in putting away the philosophical questions and just calculating and making further discoveries. So from that perspective, it's been brilliant. But there are many unanswered questions, and those have to be addressed. And the many worlds interpretation is one step in that direction. I think a lot of ground needs to be covered, but that's where we are today. Priyam asks, the Big Bang should have created equal amounts of matter and antimatter, but we don't find it to be so. A hypothesis says that all this vanished antimatter is what helped primordial black holes to grow into ultramassive black holes, quasars, such as TON 618, which is 66 billion solar masses, etc. So it may be even bigger now. So can you please explain this? So what you are asking is about why do we only observe regular matter in the universe? Why don't we observe antimatter? The universe should have created, the Big Bang should have created equal amounts of matter and antimatter. We expect the universe to be neutral, right? Charge neutral, matter neutral, all that. And therefore, where is the antimatter? So one of the proposed solutions to this problem is that maybe antimatter exists in the non-observable universe. Maybe there are regions of the universe in which regular matter predominates, and maybe there are regions of the universe where antimatter predominates. So, and maybe we are not able to see those, maybe because maybe the actual universe is much larger than the observable universe, and maybe the antimatter is somewhere else beyond our cosmic horizon. That is one possibility. The other possibility, the other theory or hypothesis, is that the Big Bang gave rise to two universes, a regular universe and an anti-universe. So the regular universe contains regular matter, the matter that we are made of, and the anti-universe contains antimatter. And it's the kind of universe where time flows backward or whatever, right? So that's another hypothesis. So that could possibly explain this problem. So this problem that you speak about is called the baryon asymmetry problem, or the matter-antimatter asymmetry problem. As of today, we don't have an explanation for why matter predominates over antimatter. There are a number of theories, like I said, but none of them has been proven thus far. So it is an open, unsolved problem in physics as of today. Akash asks, why is there such a huge temperature difference between the sun's north and south poles? Good question. So, from what I recall, there is a several percentage, maybe 6, 7, maybe even 10%. I don't think 10%, but a few percentage points of temperature difference between the North Pole and the South Pole. I think the South Pole of the sun is currently hotter than the North Pole, a few percent hotter. And what is the reason? What causes this is the question. So if you look at the Earth, for example, even the Earth has a temperature differential. I think the North Pole is warmer than the South Pole. In the case of the Earth, we know that it's because of the difference in the distribution of land mass in the northern hemisphere and the southern hemisphere. There is much more land mass on the northern hemisphere, and there's much more oceans in the southern hemisphere. And that is one of the reasons why the southern hemisphere is cooler and the south pole is colder than the north pole on the Earth. Now we know that the sun's um, polar regions are where the magnetic field of the sun comes out, and that's where the solar wind emerges to some extent. So maybe it's a magnetic phenomenon that causes the difference in temperature. And it's been observed that when the solar magnetic field flips every 11 or 14 years, I think it's every 11 years. So even when the magnetic field flips, the temperature differential of the sun's poles also flips. So it is clearly something that's related to the magnetic field of the sun. It is driven by magnetism, but the exact mechanism is thus far unknown. So as of today, we don't have a clear answer of why we have a temperature difference in the poles of the sun. What causes this? We know it is related to magnetism. It is some magnetic mechanism that is causing this. But what exactly it is, we don't know, because we are unable to look inside the sun. We have certain spacecraft near the sun which are observing it, but we can't really gauge what's happening within the sun. We have an idea of the interior of the sun. There is a convection zone and there's the core of the sun and all that. We know that it takes maybe 1 million years for a photon to actually emerge out of the sun after it's produced. But there is a lot about the interior structure of the sun that is not known to us. What are the processes? What are the mechanisms? We still don't know very well. So even this question as of today is still an open problem. It's a mystery. Excuse me. Mandar asks, string theory is failing. What do you think will replace it? So string theory is a theory that can be considered to have failed. I'm not saying it is entirely completely wrong. It is well motivated. The motivation is good. It is to find a theory that unifies quantum field theory and gravitation. But the problem is that string theory is extraordinarily complicated. The mathematics is very, and that is not the only problem. It doesn't make any testable predictions, and it is not falsifiable. A good scientific theory, or any scientific theory, has to be falsifiable, and it has to make testable predictions. String theory does neither of these things. And that's why many scientists, many physicists today are of the opinion that it is time to move beyond string theory. So what will replace it? As of today, we don't have good alternatives to replace it. The objective is to find a way to reconcile quantum field theory with general relativity, to make these quantum fields work in curved space-time. So we have not been able to find a way of doing this. String theory was a step in the direction. Another theory which is a step in the same direction is loop quantum gravity. I have a video on loop quantum gravity on this channel. You can check it out. So loop quantum gravity is a theory that seeks to solve this problem. As of today, it's not able to do that, but it is a good development. So to answer your question in brief, as of today, we don't know what will replace string theory. String theory itself is not a very valuable theory. It's not really given us any solutions or any answers to the big problems, right? So what we seek is a theory that's able to reconcile quantum field theory with general relativity. It will be a step in the direction of grand unified theory. So what should replace it eventually is a theory that reconciles quantum field theory with general relativity. As of today, we are nowhere near that. But I think loop quantum gravity is interesting. It could be a step in the right direction. Okay, so why are scientists trying to merge gravity and quantum physics, even though gravity is just the curvature of space time? So here's the motivation of trying to find a theory that unifies or reconciles quantum field theory with general relativity, which basically, like you said, is in a way the curvature of space time. It's how mass affects space time, how mass curves space time, and it's also about how curved space time tells mass how to move. So that is general relativity. Quantum field theory is about the 17 known fields of the various particles of the standard model. So why are we trying to merge this? Because we are trying to do this because there are a number of very prominent and very massive unsolved problems in physics. We have two glaring issues. There is dark matter and there is dark energy. Dark matter is something that comprises about 20-25%. How much is it? 24% of the matter of the universe. I may have the percentage wrong. Don't hold me to that. 20-24% is dark matter approximately of the entire matter energy composition of the universe, and about 70 or 71% of the matter energy composition of the universe is dark energy. And we don't have a clue as to what dark matter is or what dark energy is. So only 4% roughly of the universe is what we see. 96% is invisible. It's dark. We don't have a clue as to what it is. And it is something that seems to interact with ordinary matter gravitationally. So it is something linked to gravitation. It seems to only interact through gravitation and not through the other three forces. There are four known forces: the strong nuclear force, the weak nuclear force, electromagnetism, and gravity. So this dark matter seems to interact only gravitationally. It doesn't seem to feel the other three forces. And dark energy is even more mysterious. It seems to be a repulsive form of gravity. It seems to be anti-gravity of some kind. And it is there everywhere. It permeates all of space-time. It permeates all of our universe. And we don't have the faintest idea of what it is. And that is why, because we only understand 4% of the universe, and that too very poorly. That is the reason why we are trying to find better theories of physics. And the thinking is, and the thinking is right, that if we are able to find a theory that reconciles quantum field theory and general relativity, then we will get better insights into the nature, into the true nature of our universe. There are so many problems. We don't understand what black holes are. According to general relativity, there's a singularity inside black holes, a point of infinite density and infinite curvature, which is unphysical. So clearly, general relativity breaks down in this region of space inside black holes. So these are the problems in physics today, and that's why we are trying to reconcile general relativity with quantum field theory, which will basically give us a better idea of what our universe is like. So that is the motivation for doing this, and it's very important that we do this to understand our universe better. Ayush asks, what is negative mass? So negative mass is something that has never been observed, but yeah, you can play around with the mathematics in equations of physics, and yeah, you can basically try and see what are the properties of negative mass. So I think I have spoken about wormholes in a previous episode. I think I have a small clip about that. So wormholes are something that tend to pinch off. They want to close shut. And to keep a wormhole open, one of the solutions is to use some kind of exotic matter to keep that tunnel open. And one of the proposed solutions is to use negative mass. So negative mass is something that would have a repulsive action. We know that gravity is attractive. If I have a pen and I leave it like that, it's going to fall down. It's going to go towards the center of the Earth. So that's a repulsive, that's an attractive force. The center of mass of the Earth attracts this mass towards it. That's an attractive force. In the case of a negative mass, it would actually repel a positive mass such as this. So that would be a repulsive form of gravity. So if negative mass does exist somewhere, it would repel regular masses, normal masses. So that's what negative mass is. And how do we know it would be repulsive? We just have to put a negative sign in the equation for the gravitational potential, and we see that it causes a repulsive effect. So that's what negative mass is. We have never observed any sign or evidence that it actually exists somewhere in the universe. But from the point of perspective of mathematics and physics, it's not something that's impossible. One could have it. It does fit into the equations of physics, and it does produce the effect of repulsive gravity. Dominic asks, what is the future for students in India who look forward to becoming astronauts? As of today, only test pilots in the Indian Air Force are eligible to be astronauts, because you need a certain set of attributes, mental attributes, psychological attributes, and physical attributes to be able to become an astronaut. And military test pilots have all those attributes, right? So as of today, it's military test pilots who are being trained for the Indian human space flight program, which may take off in the next couple of years. Maybe the first flight of Indian astronauts will take place in the next 2 or 3 years at most, I think, from what I hear. So as of today, you have to be a military, an Air Force test pilot. In the future, if India does decide to augment its human space flight program, if it becomes more ambitious in space exploration, then maybe you would find maybe scientists or engineers or biologists or chemists or physicists traveling into space as astronauts. That could happen. And in the future, maybe space tourism may take off, in which case, if you are very rich, you may be able to buy a ticket into space and be in orbit for about 5, 10, 15, 20 minutes, see the curvature of the planet and experience weightlessness before you come back down to Earth. But for students, for ordinary people who are not millionaires or billionaires, as of today, it is very hard to become an astronaut. But maybe in the next 20 years, if India does become ambitious and start a human space flight program to the moon, to Mars, etc., then there could be a good future for students who wish to become astronauts. In which case, there would be a training program for astronauts, etc. You would need to have a certain kind of psychological profile and certain physical attributes. You need to be fit and all that. And if you are able to go through this rigorous program, you may be able to become an astronaut. But that is all currently in the realm of fiction. As of today, India hasn't taken the first step yet. The first human space flight still hasn't taken place. So it's all in the future. But I hope that in the next 20, 30 years, Indian students will be able to have a realistic ambition of becoming astronauts and traveling into space. I hope it happens. Okay, one more question. If our character, behavior, physicality, all that took from the genes of our parents or ancestors, does that mean that we are just that accumulated or upgraded version of physical intelligence with our own self-consciousness? See, we are a product of the genes of our ancestors. If you go back 10 generations, you may have more than 1,000 ancestors. It's not just one lineage. We are a combination of multiple lineages. And if you go back 1,000 years, you may be a combination of several thousand lineages, right? So we are the sum total of the various attributes and characteristics of our ancestors, right? So that's what we have inherited, and it does determine to a great extent our various physical, mental, psychological properties, right? How tall you're going to be, how physically strong you're going to be, how intelligent or not you will be, what sort of appearance you have, what's your eye color, hair color. what's your skin tone, and whatnot, all that, right? So that all comes from your genes, from your genetics. But there's something that we learn as well. There is nature, which is your genes, and there's nurture, the kind of environment you grow up in, the kind of influences you're exposed to, and the kind of things that you find an interest in. So if you study certain things, or if you have a certain kind of education, you are going to become maybe more intelligent, maybe more knowledgeable, etc. If you take two twins and you put them in two very different environments, they're going to become very different people. So it's not just the genes, it's also the kind of environment that you grow in. So that's what determines overall the kind of life trajectory that a person will take. One more question. Will humans ever be immortal? Is what Shreyas asks. Well, as of today, it's not possible to make humans immortal. There's a lot of research being done in the West in that direction, how to reverse aging, etc. It's all about the telomeres. So we have human chromosomes, and the ends of the chromosomes are called telomeres. And it is found that as a person ages, these telomeres become shorter and shorter, and that seems to be linked very strongly with the process of aging. So if you can reverse the shortening of the size of the telomeres, then the thinking goes that you may be able to either stop aging or even reverse it. So research is being done in the direction. The other way to extend human life is to replace organs. So if you can, well, acquire organs from somewhere, maybe go to China, or if you could grow organs synthetically, then you could replace a person's heart, liver, heart, lungs, liver, kidneys, spleen, even eyes, skin, whatnot, right? It may be possible to do that. So that could extend the lifespan of a person, maybe teeth as well. But what about the mind, the brain? And that is the real big question. Can you extend the mind? Can you keep the brain functioning like it used to function when you were, like, let's say 20 years old? Is it possible? So what one finds is that as you acquire new memories, the brain actively forgets memories that it deems to be unimportant. So as you progress in life over the years and the decades, you learn new things, you absorb more information, new information. But in that process, the brain also erases certain information that it deems to be not important, right? So if a person were to live 100 years or 200 years, it's possible they may become a completely different person because all the old information is gone and they have acquired new information. And it's also possible that the brain may not be designed to last that long. Defects may come up in the brain, Alzheimer's disease, various plaques, Parkinson's disease, and whatnot, right? So we don't know if it is possible to extend the lifespan of the brain. And even if we are able to do that, the memories that are and the information that's absorbed may turn you into a completely different person. So these are the challenges that we face in possibly becoming immortal. So the question is it even desirable to live that long? Is it a pleasurable experience? Just keep on experiencing things, or is it going to have problems? Is it going to cause problems mentally, emotionally, psychologically, etc.? So we don't know that. So I don't know if it is actually desirable to be immortal. That's the answer. All right, let me take a couple of live chat questions. Okay, this is an interesting question by Dungar Singh Chauhan. Is it safe to create a black hole in a lab? What are its negative and positive aspects? I think it's safe enough to create a very small microscopic black hole in a lab, because a microscopic black hole is so small it's going to explode immediately through Hawking radiation, through the process of Hawking radiation. It is so small and so hot that it will evaporate explosively almost instantaneously. So when the Large Hadron Collider was going to be turned on, there was this concern that it would create micro black holes in its collisions. And the calculations were done, and it was clearly shown that it would pose no threat to life on Earth or to the planet itself. It would not pose any problem. So as long as we are creating micro black holes, there is no real problem. But if one were to create a larger black hole, then it could possibly swallow up the entire planet. That is a possibility. But as of today, we don't have the means of doing that, right? We don't have the means of doing that. So it is all theoretical. Uh, as of today, it's not possible to create black holes in the lab. Okay, one more question. Let me take one more question. Let me see. Give me a moment, please. Okay, Simpo asks, why doesn't the moon have gravity? It does have gravity. The moon has gravity, but its gravity is much less than that of the Earth. The mass of the moon is about 1/6 of that of the Earth, and therefore its gravity is 1/6 of that of the Earth. So if your weight is 60 kilos here on Earth, if you go to the moon, your weight is going to be 10 kilos. So there is gravity, but the gravity is much weaker. It's 1/6 that of the Earth. So that is the deal on the moon. Okay, let me take any other questions. Akash asks, what is a Boltzmann brain? A Boltzmann brain it's a thought experiment. It says that there is a very small probability that the various atoms, etc., of the universe could spontaneously combine to create a fully functioning human brain somewhere in the universe. There is a very small non-zero probability that this could spontaneously happen. It's almost impossible, but it's not entirely impossible. So such a brain that would spontaneously assemble itself on its own somewhere in the universe is what's called a Boltzmann brain. And there are a number of thought experiments that people have done with this, all in the realm of the question of what consciousness is. So that, in very brief, is what a Boltzmann brain is. It's an interesting topic. Maybe I could discuss it in more detail in a future episode. Okay, I think that's it for today. It's been over 90 minutes. Thank you, guys. Thank you, everybody, ladies, gentlemen, all of you, for your questions. I appreciate it very much. Thank you for participating. And I will see you very soon in the next episode. I wish you a good day, a good night. Take care. Bye bye.